All right, guys. Good to see that you came to the YouTube video for your answer key. It's great to know. I want you to understand that all these problems have a ton of different ways to do them. So what I'm going to do is I'm going to start the first step that I think is most appropriate and I think is the best first step. Then I'm going to do a little bit of work, but I'm not going to finish all the problem as we get through the whole thing. I'm just going to give you the answer. And I do that because there's a ton of different ways to do these problems. The answer is important. The work is very important. But the first step is almost one of the important things. So if you're doing the right first step, the whole problem gets significantly easier as you go through it. So that's what we're going to wind up doing for these problems. If you need me to fill in the gaps, I'm more than happy to do that. Please email me at my school email address, and I'll get back to you. So on this first problem using substitution, take a look at it. It's using substitution. Notice that the first equation is already solved for x. Since it's already solved for x, we can simply take this and substitute that in for x, and that's exactly what we're going to do. And I'm going to write it right here. So we get 5y minus 4 times the thing that x equals. And then you'll notice that we turn around, we get an equation just with y's in it. And then we're going to distribute 5y plus y minus 8 equals 16. Then you keep going to solve this equation. You get 6y minus 8 equals 16. And as you progress, you get y equals 4. And then you turn around, you take that, and you substitute that into that equation right there. And you'll wind up getting x is 1. So your answer is 1, 4. All right, let's go to the next one. Here we go. Using elimination. So we need to figure out what we need to multiply by. Now we need same number, same variable, same number, different signs. Now it's set up for x pretty closely, but it's even easier to get the y's to be the same variable, same number, different signs. To get the y's the same number, we just need to multiply the numerator by 2. We got to or not the numerator, but the first equation by 2. We multiply all the stuff up there by 2. And then we go ahead and add straight down. That's 0. That's 0. That's 15x, and that becomes positive 5. So we get x is 1/3. After we get x is 1/3, we take that and we substitute back into one of the originals. I think that one's the easiest to substitute it back into. We're going to substitute it in for x. After you do that, you get y equals negative 13/3. So you get 1/3, negative 13/3. All right, next problem. Here we go. Cost of 24 oranges of 15 apples is $12.36. 15 oranges and 12 apples is $8.67. Find the cost of each orange and each apple. Well, x is the number of, or the cost rather, cost of oranges. Y is the cost of apples from the purpose statement. From that, we take a look for totals. We have $12.20 or 36 cents looking for a total. That's made up of the total cost of 24 oranges. So that total cost is going to be 24 times the amount per orange plus 15 times the 15 apples times the amount per apple. That's going to make up $12.36. And we do 15 likewise for 15x and 12y equals $8.67. To first multiply this, if you want to get rid of the x's, you multiply the second equation by 24 and the first equation by negative 15. Make sure you distribute that to all three parts. And then you crank this out. You guys already did this. You actually recorded your own video on this. And the answer is, but I wanted you guys to give it another practice, because to study for math is doing the same problems again and again until you get them right. So that's what our solution is for number 3. You got to work out all the intermediate steps. By the way, that looks like a smiley face. Hello. Hi. Anyways, all right, next. Number 4. Sum of two numbers is 125, and the difference is 47. Find the two numbers. So those wind up being our variables. X, we're going to be first number. We're going to say first number. Y, we're going to say is the second number. And then let's see what we get. Let's take it apart. The sum of two numbers is 125. Sum means add. So the sum of two numbers is 125. And then on the second one, their difference is 47. Difference is subtract, so we just subtract them and get 47. Now, for this one, I would straight up use elimination because it's already set up. That's 0. You get 2x equals 125 plus 47 is 172, and you get x is 86, and then you go ahead and then you end up finding your y as well, and you get y is 39. So the two numbers are 86 and 39. Woohoo, we did it. Let's go to the next problem. There's 29 coins in a car, in my car, and only nickels and dimes worth $2.30. How many nickels and how many dimes do I have? To find variables, you want x is number of nickels. From the purpose statement, it says how many nickels. That's number of nickels. Y is number of dimes. From the purpose statement, it wants to know how many dimes you have. So let's turn around. You have a total of 29 coins. That means those two amounts of coins add up to 29. Number of nickels plus number of dimes equals 29. That's where we get that equation. But you only have nickels and dimes for a total of $2.30. So that's another total value, but that's made up of the total value you have in nickels, which is going to be 0.05x, and then the total amount of dimes, which is going to be 0.1y, because they're 10 cents or $0.1. And for nickels, they're 5 cents or $0.05. To do this, I would do it by elimination again. I would multiply the numerator by negative 0.1. Because I feel like that's the easiest to do, to multiply the numerator instead of multiplying the denominator, and then 0.1 because that's easy to multiply by 29. That's why I'm doing it. Negative 0.1 y equals negative 2.9 over 0.05x plus 0.1 y equals 2.30. And then we go ahead and we add it and things start dropping out. And you wind up getting x equals, you end up getting x is 12. So that the number of nickels you get is 12, and then when you take that and you substitute it back in, I would substitute it back in that problem, and I'd wind up getting then 20, we'd get 17 dimes. Alright, next problem. You have a total of $160, you save $7 a week. Your friend has a total of $210, and he saves $5 a week. How many weeks will each of you have the same amount of money? Same amount of money in weeks. Those are our two variables. So x is number of weeks. Y is number of, or amount of money, and that's in dollars. Straight from that purpose statement. From that, let's take a look. You have a total of $160 and you save $7 a week. Okay, the amount of money that you have, that was Y, that's actually a representation of the total amount of money that you have. And we're asked the same from the purpose statement, how many weeks for the same amount of money. So we're talking about the total amount of money that you get and the total amount of money that your friend gets, and those are going to wind up turning into the two equations. So let's write an equation for the total amount of money that you get. You started out with 160 and then you added $7 a week, and we made a variable x being our week, and that's going to equal the amount of money that you have, or the total amount of money. That's going to give you your equation. The equation for your friend, it's going to start out as 210 plus $5 a week is going to be y, and that's the amount of money your friend needs. We want to know when you're going to have the same amount of money, so these y's have to be equal. So what we're going to do is we're going to substitute this right there for y, and we're going to wind up getting 210 plus 5x equals 160 plus 7x, and then we're going to solve that equation for x and see what. So if you subtract 160 and then you subtract from both sides and then you subtract 5x from both sides, you get 50 equals 2x, and you get x is 25. So that's the amount of weeks, because that was our variable for x. 25 weeks to have the same amount of money. All right, next one. All right, guys, this one I actually want you to skip. We're not going to work on doing that. We're not going to worry about these mixture problems on here. All right, so let's take a look at number 8. Solve the system of equations using any method. Simplify your answers. I think elimination is the best method because those are set up. So I would just go about adding straight down. And I'm just going to give you the answer to this problem instead of doing all the work, because you know, there's a whole lot of ways you could go about getting that answer, so I'm not going to go ahead and mix it up if you wanted to do a different way. But I think that the easiest way to do that problem is elimination because of those two are set up. When you solve this, you actually get x to be 15 and you get y to be 15. Now this next problem, 9, the easiest way is to do substitution because it's already set up. So we take that and we put that right there in for x and rewrite it. So our first step winds up being this equals 0. And then you distribute and then you multiply out until you get your variable for y is the first one that you wind up getting if you do the same. So you get y first and you're actually going to get a fraction, an improper fraction. After you do that, you take it and you substitute back into the second equation, which would be that one, and you wind up getting, you get rid of your fraction on the second equation and you get x equals 4. So you get 4 negative 32 thirds. Next problem. This one is not really set up for either of them, so you could do your favorite. My favorite is elimination. If I was doing elimination, I would multiply the first part of the problem by 4 and the second equation by 3, and that's going to get the x's to drop out, and we're going to eliminate x's. Okay. However, if you're doing substitution, the easiest variable to solve for, actually it doesn't really matter. As long as you don't work to solve for the x right here, every other one is pretty easy. That stood out to me just because it seemed like it was a good one. So I would minus 4x if I was doing substitution, and then I would divide by 2, and then this is what I would turn around and substitute in. So no matter which way you wind up doing it, you get an answer of 2, 6. All right, number 11. I would actually do this by elimination. Why? Because I like elimination better, and I would multiply the first equation by 2. If we do that, we wind up getting this. And then we add straight down, and guess what happens, guys? That's 0, that's 0. So we get 0 equals negative 4, and that's no solution for this problem, which means that the two lines are graphed and they're parallel, but they have different y-intercepts. Parallel lines with different y-intercepts are going to give us no solution. If you did this a different way, if you did this using substitution, I would turn around and solve for that y. So I would add x to both sides, and I would get y equals x plus 7, and that's what I would take and put in there. 2x minus 2 times x plus 7 equals negative 18. And then distribute, and you get negative 14 equals negative 18, which again doesn't match, so it's no solution. Alright guys, the easiest way to do these kinds of problems is to take these values, x and y, and substitute them into the equations and see if it makes a true statement in both the equations that you want to get. So I'm going to do that right now. With the magic of YouTube, I'm going to pause it, show you what it's like after you put them in and what numbers you get from each setup, and then tell you which one's the right answer. So after you put them in, they look like this. Now the yellow matches with the yellow and the blue matches with the blue vertically. You got to see if it makes a true statement in both of those equations. Does negative 2 times 1 plus 4 equal 2? Okay, that one's true. Is 1 plus 2 equals 3? That one's 2. That means it is a solution to A. Let's see if it's a solution to B. Okay, negative 2 times 1 plus 4. That's 2. That checks. 1 plus 3 isn't 7, so this one's no. 2 times 1 is 2 plus 1 is 3. That's not 2, so this one's a no. Then here you wind up getting 2 equals 4, and so that one's a no. And so the first one is our solution. So number 13 for a solution to this system, solving a system equation which expressing can be substituted in for x in the second equation. So we're looking to put it into the second equation, and we want to put it in for x, so we locate the x variable in the first equation and we solve for that. So I'm going to minus 2y from both sides, and we get negative 2y plus 15, and that's what you wind up substituting back in to the second equation to solve it. So that answer is going to be, that answer is 8. Next one. Alright guys, so here's the answer to 14 through 16, just multiple choice questions. It goes C, C, A, and let's take a look at the last one. How many solutions does this graph have? Well, those lines keep going out forever. They're going to cross in one spot. Alright guys, email me if you have any questions, of course. Nice job making it through the end. Proud of you guys. Keep working hard. Remember, studying for math is repeating math. See ya.